Good morning student, welcome to my class. So far we discussed what is velocity, speed, distance, displacement and different type of speed and what is average velocity and instantaneous velocity. Clear? Okay. And we already discussed what is acceleration. Acceleration means the rate of change of velocity of a body with respect to time is known as acceleration. But we already discussed that is constant acceleration. So what is constant acceleration? If a body cover with same velocity within a interval of time, clear, that type of motion we can say that is accelerated motion. If speed increasing continuously after certain interval of time, suppose I am taking here, suppose this distance and here time interval, that is delta t, suppose 1 second, and here body cover with speed v1, and next time interval how much, suppose here speed 0 and here velocity suppose 5 meter per second, and another same interval time, that is here 1 second, and it will cover with same velocity and here 10 meter per second, and here velocity how much, final minus initial, because acceleration of a body can be calculated by using formula, that is a equal to v2 minus v1 by t2 minus t1. We can write, clear? So here this interval is velocity, we can write acceleration a means v2 is here 10 minus v1 is here 5 divided by d2 minus t1, we can write that is delta t, and given delta t is here 1 second, that means we can write here 5 by 1 meter per second square is acceleration. And here also same acceleration, how much? Here acceleration a equal to final minus initial, then 5 minus 1 divided by delta t, or time we can write t2 minus t1, clear? So here 5 minus 0 is here, so 5 minus 0, time interval is here 1 second, that is meter per second square, clear? But velocity increase 0, then 5, then 10, after same interval of time, that is 1 second, it will increase its speed, again it increases its speed 5 meter per second, means here that is 15 meter per second, clear? So velocity increase continuously for a certain interval of time or same interval time, but acceleration remain constant, clear? That type of acceleration of a body or that type of motion of a body is known as accelerated, uniform accelerated motion, clear? Retardation means if speed decreasing, clear? And the direction of retardation always opposite to the velocity, decreasing velocity we can say. Suppose here velocity, that is I am writing here 10 meter per second, and again here 5 meter per second, and again here 0 meter per second, but particularly moving in this direction means speed decreasing, but acceleration now opposite direction, clear? We already discussed about this concept, clear? Okay, now we will start here kinematic relation, but we have to use here this equation, that means we have to use here for uniform accelerated motion. If acceleration of a body remain constant, then we can apply this kinematic relation, otherwise we cannot apply this kinematic relation, clear? We will derive here 4 kinematic relation and by using calculus method. Or integration method, we can say integration method or calculus method, clear? Kinematic relation or equation of motion or kinematic equation in calculus method or integration method, we already know 4 relation. So first equation, first kinematic equation, or we can say velocity of a body after time t, clear? So we have to find here a expression which contain velocity and time. Suppose for straight line motion, or you can say this equation is for straight line motion, this straight line motion, and this is origin, and here origin means we have to measure all the distance and displacement from this point, and that point is known as origin. Okay, and here 0. Suppose when time t equal to 0, time t equal to 0 means observation start here. Observation start, starting point. Clear? When time t equal to 0, we observe that there is a car which moving with certain velocity, and when time interval 0, and this car which cross this point, which cross in front of me with a certain velocity. Suppose I am writing here, there is a body or car which moving with certain velocity, suppose u, at time t equal to 0. After certain time t, suppose after time t equal to t second, means here 0 second its velocity u, but after certain time t it reaches at this point. Suppose this point is A, or this point you can say this point O, and here reach at point A with another one velocity. This is initial velocity. After time t it attain final velocity v. Why? Because we consider here uniform accelerated motion. Uniform accelerated motion means velocity increase gradually. Clear? So here we have to write that is acceleration of a body A equal to constant. Constant acceleration. Velocity increase but acceleration constant. Clear? Okay. So in this case we have to find a relation v t and initial velocity u. So how can we find a relation? Because we already have a relation that suppose in integration method, first we have to divide this, because it cover a distance like this here, distance, this distance, or we can say if total time taken 0 to O to A, that is t second, final minus initial, t minus O is t. So suppose first we have to calculate what is the speed of a body for a certain interval of time, very small interval. Suppose I am writing here very small interval of time dt. In this time interval, the body, the speed of the body or speed of the vehicle or car, suppose that is dv. Clear? If small interval of time dt and its speed, it moving with a speed that is dv. Clear? So in this case we can use a relation that is known as instantaneous acceleration, and how much, that is a equal to dv divided by dt. Means differentiation of velocity with respect to time, or you can say small interval of time it traveling with a velocity dv, which is equal to instantaneous acceleration. Clear? Now we can write here dv equal to a dt. Clear? Okay, but we have to calculate total velocity within time interval 0 to t. So how can we find total velocity? Means when time t equal to 0, when time t equal to 0, its initial velocity u. Clear? Time t equal to 0, we can write here initial velocity equal to u. After time t equal to t, it attain final velocity, that is final velocity of a body, that is v. So we have to use integration here, and integration symbol like this. Okay, here a is constant quantity, so you can take it out of the integration. So you can write here integration, a integration, that is dt, and integration is here, that is dv. Now we have to use limit, because here limit given when time t equal to 0, its velocity u, means here dt is variable, dt each interval time variable, because here time 0 and here time t. So when time t equal to 0, time t equal to 0, at that time its speed u. So we have to write time t equal to 0, that is u speed. Car moving with u speed. After time t, here time t, it moving with velocity v, it moving with velocity v. This is known as definite integration. Clear? So if we use, or we already know, the integration over dx which is equal to x to the power or some limit a to b, that is x to the power n plus 1 by n plus 1, where n cannot be negative, means minus 1, and we have to use here a limit, that is a and b. First we have to use upper limit, then we have to use lower limit, that is a negative sign. So in this process we can write dv and its integration similar like dx here, that is the integration of dx can be write in this format by using this relation. Then we can write here, that is x to the power 0 dx integration over a to b, means x to the power 0 plus 1 by 0 plus 1 equal into limit a to b. That means we get here, that is x limit a to b, like this. So the integration of dx which is equal to x. Similarly, integration of dv can be write v and its lower limit u v equal to a dt. Integration of dt can be write t, and here lower limit 0, upper limit t. Now use limit. First we have to write v in place of v, so then answer v. Now we have to use a negative sign here, then we have to write u in place of v, minus u. Clear? And here a, then we have to use t is here, minus 0, we have to use lower limit here, then a t equal to v minus u, or v equal to u plus a t. This is known as first equation of kinematics, and this equation is very important, and this equation we can apply only when the acceleration of a body which is constant. This relation is only valid for constant acceleration. Clear? And what is time? After time t interval, its velocity is v. Suppose when time t equal to 0, suppose initial velocity 0, means here time t equal to 0 and initial velocity 0, means body initially at rest. After time t, it cover a certain distance with velocity v. So in this case velocity how much? That is v equal to u, means 0 is here. So 0 plus a t. This is known as relation. If particle moving with constant acceleration, acceleration should be constant. Clear? This is known as first equation of kinematics. Next come to second equation. Second equation. So second equation means you have to find here distance covered by body after time t second. Clear? That means suppose time t equal to 0, the particle which start moving in straight line direction, means this direction. When time t equal to 0, its starting point here, means we have to take here origin. Origin means all the distance can be measured from this point. When t equal to 0, its initial velocity u, like same condition. Okay, after time t, when time t equal to t and its velocity v, but it cover with certain distance in straight line, and the distance is s, and this body which moving with constant acceleration. Clear? So here we have to calculate a relation which containing displacement or distances, final velocity v, time t and initial velocity u. Clear? Okay. So total distance within time t equal to s, but this is total distance. So in this case we have to calculate with integration method. Why? Because in this case the velocity of the body which is changing, this is not constant velocity. Clear? Because why? Because acceleration is here constant, so velocity must be increased. So in this case we have to write here for we already have relation, that is v equal to, we can write here, that is ds upon dt. Means if we take small interval of time dt, then it travels, suppose it cover a small displacement, we can write ds. So that v equal to ds upon dt or ds equal to v dt. Clear? Okay, so here we already have relation, that is v. V is here how much? That is v equal to u plus at. Then u plus at and dt, and this is ds. But we have to calculate total displacement or total distance within this time interval or after time t, means this distance we have to calculate. So how can we calculate this distance? In this case we have to calculate this distance by integrating to this equation. So by integrating to the above relation with proper limit, we can write that is ds which equal to u plus at integration over dt limit. Okay, limit is important. When time t equal to 0, initial displacement how much? Time t equal to 0, this is origin, and here initial displacement s equal to 0. Clear? Where s equal to 0. After time t time interval, it cover with displacement s. So it cover with displacement s. So displacement s. So we have to use here because del dt and dt which is variable here. So when time t equal to 0, displacement how much? That is 0. After time t, it covers displacement is s. Clear? Okay. So if we integrate this relation, the integration of ds we already know that is s lower limit 0 and upper limit s equal to. Now separate this integration with this term, individual term. So you can write u integration 0 to t dt plus, here a is constant quantity, so you can write that is t dt integration 0 to t. Clear? Or if you solve this relation, then we can write which equal to, here u is also constant. Why? Because this is initial velocity, this is constant, initially constant. Clear? So we can write, we can take it out of the integration, so we can write here u. Clear? And the remaining part dt, and its integration we already know, u is here constant quantity, and dt integration can be write t, here lower limit 0 and upper limit t is here, then plus a is constant quantity, and we already know t dt, that is integration of x to the power n dx, integration how much? That is x to the power n plus 1 by n plus 1. So if we use this relation here t dt, then here limit here power is 1. So t to the power, you can write here t to the power n plus 1, 1 plus 1 which is equal to 2 divided by 2, and limit is here, that is 0 to t. Clear? Now use upper limit and lower limit. So here if you use upper limit, then we have to use s minus 0 equal, here u is constant, that is u is constant quantity, and first we have to use here upper limit in place of t. Clear? So t minus 0, this is lower limit, plus here a, or you can write a by 2, 2 is constant, so you can write here a by 2. Now we have to use here upper limit, that is t square minus 0. Then this relation can be write s equal to, that is ut plus 1 by 2 at square. Clear? This is final expression, and this is also important expression. And this kinematic relation or second equation of kinematics is only valid when acceleration of a body should be constant, where t is total time, 0 time to time t, and total displacement or distance from this time interval. Clear? This is known as first equation, and this is second equation. Next start third equation of kinematics or third equation or equation of motion of kinematics. Hela, we have to find a relation between velocity, displacement, so that means initial velocity, displacement and acceleration or final velocity. Clear? Okay, so in this case, suppose in straight line motion, suppose this is initial point and this is origin. Origin is important because all the distance can be measured from this point. When time t equal to 0, suppose there is a body which moving with certain velocity, and that velocity is known as initial velocity of a body. Clear? And at this time t equal to 0, distance traveled by the body which is s equal to 0. Clear? Okay. So if this body which moving with a constant acceleration, this is important point, and after certain interval of time t or after time t it reach another point A with velocity v, final velocity v, and it cover a displacement or total distance, that is s. Clear? So you can write here, so when time t equal to 0, at that time initial velocity of the body is u, and distance cover, that is s equal to 0. This is initial case. Then come to final case. When time t equal to t or after time t, its final velocity, that is final velocity of the body v, and here distance covered by the body after time t which is s, means it cover this distance after time t, that is s. So you can write here that is s. But we have to find here a relation containing initial velocity u, final velocity v and distance s. That equation is known as third equation of kinematics. Clear? So in this case we already have relation, that is a equal to dv by dt. This is known as instantaneous acceleration, and this acceleration, because we already know v equal to ds upon dt, means the rate of change of displacement which is equal to velocity. Clear? Okay, so here the rate of change of velocity with respect to time equal to acceleration. Similarly we can write here, that is d by dt of, that is v. So here v we can write, or again d by dt of v, and v is here ds upon, or we can use another format here like this. So we can write here, that is dv divided by ds. Suppose dv divided by ds into ds divided by dt, same thing, because ds cancel here, and the remaining part again ds by dt. We can write differentiation in this format, and this is known as chain rule. Clear? So in this case ds by dt equal to v, so you can write here, that is dv by ds into ds by dt is v, and here acceleration a. Clear? Okay, now multiply this ds with a, so a ds equal to how much? That is v and dv. This is known as equation. Suppose this is equation 1. This is first equation. Equation number 1. Then a ds equal to v dt. Now integrating to the above equation with limit, then we can write a ds integration equal to v dv integration. Clear? And we have to use here a limit, because here variable is ds and here variable dv. So when initial velocity, this is velocity, so when velocity of a body or initial velocity of a body u, initial velocity of a body u, at that time this is displacement of a body, that is 0. Initial velocity u and displacement 0, then we can write here 0. Then final velocity of the body v and displacement s, so final velocity v and displacement s is here. So in this way you can use upper limit and lower limit. Clear? And what is a? A is constant quantity, so you can write here a integration over ds limit 0 to s equal here v and v dv, so v here dv, initial velocity u to final velocity v. Now we have to use formula here. Then what is the differentiation integration of ds? The integration of ds which is equal to s, but here a constant quantity a into s integration lower limit 0 upper limit s equal v dv. The integration of v dv which is equal v square by 2. We already know how to calculate integration by using formula u, and upper limit v is here. So here 2. Clear? And this 1 by 2 is constant quantity, so we can write this relation a is constant here. First we have to use upper limit here, then s minus 0 equal to 1 by 2 is constant, we can take it out from this square bracket, then remaining part v square u to v 1 by 2. Now use upper limit in place of v square, then v square minus, now use lower limit in place of v square, that is u square. So and here as, if you solve this term then we will get that is 2as equal to v square minus u square, or simply we can write v square equal to u square plus 2as. So final velocity attained by a body, if its initial velocity u, then there is another term that is 2as, which addition term. Clear? And what is s? S is your final displacement or total distance covered by the body within time t, or we can say when attained velocity v. This is u means initial velocity of a body with starting point or origin point. Clear? So this equation only valid when acceleration of a body that is constant. Clear? This equation only valid for constant acceleration. Now next relation, fourth equation, and that is known as fourth equation of kinematics, and this equation is very important. That means distance covered by body, I am writing here fourth equation in kinematics, distance covered by the body in last 1 second. Last 1 second. Clear? Or simply you can say essence formula. Essence formula. Clear? So in this case, suppose the particle which is moving in a straight line path with constant acceleration, acceleration of a body is constant. Suppose its starting point here and this point is O, means origin. When time t equal to 0, initial velocity of a body, that is u, and its initial displacement or distance, that is 0. Clear? Okay. So after time t, we already know relation. How much? That is after time t, it cover a distance s. Clear? And this distance we can write this distance s into t, means The particle which is moving in a straight line path with constant acceleration, after time t, it cover a distance that is st. T means t second. Suppose 1 second, this distance, 2 second, it will this distance, 3 second, like this. Similarly, a particle cover t equal to 0 means displacement 0. After time t equal to 1 second, then it cover this distance, suppose s1. After time t to here 2 second, it cover distance s2 and 3 second, like this. But after n second means when time t equal to n second, it cover how much distance? It cover this total distance from initial to this point, and this distance is known as Sn distance. Clear? Means 1 second 1 distance, one s1 distance, 2 second s2 distance, like n second Sn distance. Clear? Okay. But come to this question again. If a body cover here, that is t equal to 0 to t equal to t, or t equal to suppose 4 second, then here distance travel, that is s4. But its time t equal to 3 second, then distance travel, that is s3. This is total distance s4 and this distance s3, and this distance, this is final distance, or the distance traveled by body in last 1 second. This distance is known as last 1 second. Clear? So final distance or final time 4 second, and before final time, that is 3 second. So distance covered within 1 second, which is equal to how much? S4 minus S3. So in this case we can use, suppose I am writing here time, that is t equal to n second, and this distance is here, this total distance covered, that is n, means this point, and time and particle cover when time t equal to n minus 1 second, like t equal to n means 4 second and n minus 1 means 3 second. So in this case the body cover this distance, and this distance we can write as n minus 1, like 3 second and 4 second. Similarly here n second, this is n second, and this is n minus 1 second. So distance cover in last second, and this is known as Sn formula, and this is the distance cover by body in last 1 second. This distance means this distance, and this distance is known as Snth. So Snth means, Snth simply we can write Snth equal to Sn final minus initial, then we get Snth. So Sn minus Sn minus 1 is known as Snth, or distance covered by the body in last 1 second throughout its motion, or if body moving with constant acceleration. Now we have to derive this relation here. Clear? So in this case we already have relation, that is when initial velocity of a body, when time t equal to 0, its initial velocity, how much? Initial velocity u, that is u, and displacement how much? Displacement is here distance cover, and this time t equal to 0, distance covered by body, that is s equal to 0, like this in 2 second, 3 second, 4 second, 5 so on. And when time t equal to n second, the distance covered by body, that is Sn. Clear? In t equal to n second, the distance covered by body, that is Sn. And when time t equal to n minus 1 second, n minus 1 second, then distance covered by body, that is Sn minus 1 second, and moving with constant acceleration of a body should be constant, means straight line motion. Clear? Next, as we know, acceleration can be right, that is, or velocity can be write ds upon dt, and v dt equal to ds, or ds equal to v dt. As we know, for constant acceleration, velocity attained by a body after time t equal to u plus at. If we use this relation here, then we can write u plus at, because v equal to u plus at into dt. But we have to find ascent formula. So integrating to the above equation with limit, then we can write here, that is ds equal to u plus at, and dt is here, integration on both sides. Then we have to use limit. Limit is important. Here time is variable and here distance is variable. When time t equal to 0, but we have to find which distance? We have to find the distance covered by the body in the last 1 second, means Sn, and we have to calculate Sn minus 1. Sn minus 1 distance to Sn1, Sn minus 1 distance to Sn distance, means this is Sn distance. So in this case we have to use that is Sn formula. When time t equal to n minus 1 second, time t equal to n minus 1 second, at that time distance covered by the body from initial point, that is Sn minus 1. So you have to write here Sn minus 1, and when time t equal to n second, means last second, n second, and at that time distance covered by the body is Sn. So you have to use here Sn. Now integrate this relation, and the integration of ds can be write s, and here limit Sn minus 1 upon limit Sn equal to u. We can divide this integration with individual term, u integration over here dt, integration n minus 1, time is here n second, n, plus at n minus 1, here n, and time, variable time dt. Clear? Now integrate this relation, but here u is constant quantity, so we can write u dt n minus 1 n, plus here a is constant quantity, a t dt, integration over n minus 1 to n, and here u dt, the integration of dt can be write t by using formula, and lower limit n minus 1 to upper limit n, plus a is constant quantity, and the integration of t we already know, and power 1, t to the power n plus 1 means 1 plus 1 by 1 plus 1, which is equal to t square by 2, and limit here n minus 1 to n. Clear? Now solve this relation. So here Sn equal to s n minus 1 to Sn equal u t n minus 1, here n, plus 1 by 2 is constant quantity, so we can take out here, so we can write a by 2 t square n minus 1 to n. Now use upper limit and lower limit. If we use upper limit in place of s, then we can write Sn, negative sign, then we have to use lower limit Sn minus 1. Complete? Then come to next term, here initial velocity u, and use limit. First we have to write n in place of t, so here n minus, now we have to use lower limit in place of t, that is n minus 1, bracket close, plus a by 2, and we have to use here n in place of t, means you get here n square minus, if you use lower limit in place of t, so n minus 1 square. Now solve this equation, but Sn minus 1 means distance covered by particle in last 1 second. So you can write here Snth equal u n in minus plus 1 plus a by 2, here n square minus a minus b whole square, and n square plus 1 minus 2n. Clear? So u and n cancel, means u plus a by 2 n square minus n square minus 1 minus plus 2n. Then n square cancel. The remaining part we can write, that is 2n minus 1 as nth. This is very important formula for mechanics. Clear? And this mechanics chapter which is related with other chapter. So this equation, this 4 equation is most important. And what is 4 equation? First equation v equal to u plus at. Second equation ut plus half at square. And third equation v square minus u square equal 2as. And fourth equation Snth equal to u plus a by 2 2n minus 1. This 4 equation is very important. What is n? N is your time. Clear? And what is u? Initial velocity, a constant acceleration. What is Snth? Snth means distance covered by body in the last 1 second, like 3 second to 4 second, 5 second to 6 second, means last 1 second. Clear? So these are 4 equation, and this 4 equation is very important, and this equation is known as kinematic relation or kinematic equation of motion. Clear? And this 4 equation we can use only when a body moving with constant acceleration. So you have to remember this 4 formula. Clear? And by using this formula you can solve different type of numerical. Clear? Thank you all.